Okay, since we're recording now, I'll go ahead and start. After trying to drill one hole for 30 minutes into that stainless steel and not getting through, I decided I don't need to mount the battery connectors where I was going to. So let's see. I was going to mount them up top here, but I had to drill through this stainless steel. Instead, I just decided to mount them on the side where I had aluminum framework. And that went much faster. And so now I'm wiring up the switches and the buses so that I can get my 3-volt or my 5-volt power supply. I've got this little, where'd it go to? This little Tobson 15-watt DC to DC converter, where you just put 12 or 24 volts in, or between up to 24 volts in, and it gives you 5 volts out, 3 volts or 3 amps filtered. So that will be my 3-volt bus for driving the Itsy Bitsy and the Raspberry Pi. Hopefully I'll get that wired up this week, going through my fuse block and so forth. Any questions about that?
None for me, Terry.
Okay. I then was going to start loading, wanting to load ROS onto my Raspberry Pi. Well, I discovered you can't use the Ubuntu 2204. You have to use the 2004. And the desktop version isn't available anymore. Or I couldn't find it, I'll put it that way. So I'm having to load the server version and do everything without the GUI. So I can then load ROS, which probably isn't a bad thing, but it just makes it harder for me since I'm not a real Unix guy.
Al, do you remember if that the Ubiquity, does that have a desktop or is that just a server version?
I don't remember, Jeff. I loaded Ubiquity on a Raspberry Pi multiple times, and I think they still have an image out there, but I don't know if it was the desktop or something trimmed down just for their distro. But I mean, I can look it up. I don't know, Terry. Were you done, Jeff, or did you want to get into that anymore?
Well, the next question is, do you use the Lino Robot? They have a pre-built image too, don't they? Do you recall on that if that's got a desktop built into it?
Again,
if you don't remember, that's fine. We could look it up, but
yeah, I don't remember specifically. When you say desktop, are you saying did they have like LibreOffice loaded on it or something? Or
no, I mean, does it bring up a desktop so you can actually run
a GUI?
Yeah.
They both definitely had GUIs. I mean, you could remote into the Raspberry Pi. I pretty much, after you got it configured, I didn't use the GUI, but they're there if you know how to get to them.
So the point is, both Lino Robots and Ubiquity Robotics have pre-built images. You just download their package, put it on an SD flash card and plug it in, and away you go. And both of those were designed for ROS. So I know the Ubiquity one at least comes with your full Ubuntu to make it work, and then it's got whatever version of ROS that they're doing is built into it already. So you just download that stuff and put it on there, and it should power up and you're ready to go. It's always
Okay,
confusing because once you do that, you don't see any ROS stuff, and that's because ROS is just hidden out under opt-ROS, the install version, whatever. So that confused Bob when he was trying to do that.
Okay, so what are those two places, or can you put the links in?
I'll track those down, because what I'll do, I'll go back to our index where we talked about this stuff, and I can come up with links to this stuff, and I'll put it in the chat.
Okay,
And I
'Cause
may
it-
not get it done during the meeting because it'll distract me a lot, but
nope,
eventually,
no worries.
by the time we're done, I can put it in the description of this meeting, so you have those. And there
I
may be
certainly-
other things available you can do that with, where you just download and put it on the card, and it comes up running. And that way, start with a fresh card, so you're not what you've already got loaded on something else. You don't have to destroy that. You can just put it on a new card. When you plug that card in, then you got a whole new. It's like putting a whole new hard drive in your laptop. So
Right. I have no problems. I mean, I've just got done downloading the image and was just booting it for the first time. So I have no problem reformatting the disk, the SD card.
And if you decide that you really want to install from scratch and you want the desktop version, I have made that work. So I can track that down if you decide you want to go that way.
If it's got the GUI, then that'll be fine.
And it's one of those things. It's not that hard to do. You point to the things, say download the binary, and then there's somebody will give you some instructions how you put that on the card. So it's make one card for say Ubiquity, and make one for Lino Robots, and make a separate card for if you're going to do it from scratch or whatever. And that way you can just plug in whichever card you want and go from there. I see Al posted something here.
Right.
Yeah, I mean, these are getting a little bit long in the tooth, but these are instructions that I wrote for myself. So there's a health warning with them that they may not work exactly like they're stated, but those are the instructions I wrote down on how to install the Ubiquity image and get
Okay.
it loaded on it.
I will read through those. I've opened the link, so I've got it. So.
And if you go
Cool.
go to ubiquityrobotics.com, I think they got a write up on what they're doing, and they're not real clear on some of these. They built these images, but there was a point where it wouldn't load on a Raspberry Pi 4, and then just magically they came out with a new version, but they didn't say anything about it, so you didn't know. But this stuff will even run on a Raspberry Pi 4 if you happen to have one of those.
Don't have any force. I've got 3 of the 3 Bs.
Yeah, that brings up a really good point, because I don't remember what I was using when I, put that image down on it. But if you have trouble, send me a Slack note. I'll take a look at whatever you've got.
Okay.
I just wanted to save you some steps there if you didn't want to do the whole thing. And I know also from Lino Robotics, I think they're the ones that have, it's called a ROS.me script. So ROS.me as one word, and basically you run that and it just downloads ROS and puts it onto whatever install you have. And Matt was a big fan of that. And I usually just end up loading everything from scratch every time. Partly so I don't completely forget how to do it, and then partly because when you get somebody else's image, you don't really know what's on it. But that's still a good way to start, is if you can get one that because the Ubiquity Robotics, they're part of Homebrew Robotics out in California, and they all seem to know what they're doing. So it's in general, that I trust their stuff, and it has most of the stuff you're going to need. It probably, even to get started, is going to have most of the stuff you need, but you can still go out, at any point and say apt-get this new package and install it on the fly. So that
Okay.
all still works out.
Appreciate it. And so anyway, I hope to get that installed, and hopefully then start testing the RS-232 connection between the Raspberry Pi and my itsy bitsy.
Have you given me a thought on how you're going to get those to talk to each other? Which in my whole rambling, I'm going to go over that and say what I just found. So I'm just curious if you've decided what you're going to do there.
Not specifically. Because I'm writing the itsy bitsy code, I can format the message however the ROS serial needs to accept it.
If you're running ROS Serial, you don't have to format anything. You just load this giant package on your ROS machine, and then you just install a library on your Arduino stuff, and it just all magically works. And I learned all this last night. I was digging through this because I was frustrated with everything else, so I went down this path to figure it out, and I was able to load it and get their examples to run. So that's I've avoided it up to this point, but it seems like it's an awful big. It's a lot bigger than I expected it to be, and my stuff is small. I just say do a print, and then at the other end retrieve it and do something with it, and so it's much simpler and more to the point. But then again, it could be that ROS Serial is the way to go. So I know Al runs that and Juan runs that. Lots of people run that ROS Serial, so we could discuss that one of these days too.
Okay. But no, I haven't. I just know that I'm going to have RS-232 connecting the two boards. Beyond that, I haven't. I figure I can format it however I need to.
So are you running RS-232 or you're running asynchronous serial between the two boards? RS-232 refers to the high voltage drivers on
okay, no
serial. So
no async.
So basically, you got the UART pins on both boards. You can hook them together, and it has nothing to do with RS-232 at that point. That's just asynchronous serial.
Okay.
Just
I stand corrected.
Just a point there, so people don't keep propagating this. And I know you told us why you're going to use that as opposed to going over USB, but we'll worry about that later.
Basically, because I don't want that long USB cord connecting the two.
I find if you look far enough, you can find short cables. You have to go on like Amazon and say short USB cable and say either mini or micro. Is that a micro connector on that board or a type C connector on your board? Or
it's a micro.
And I know I bought a bunch one time that are the short ones for the mini, but I don't remember if I went to the trouble of tracking down the cables for the micro or not. But you go out and search and say either a short cable or put in a 6-inch cable or something, and it'll bring up. You put in a 6-inch cable, it'll start showing you lots of short ones. So you can't actually just buy a short cable. In fact,
what I found was a lot of times those are just power cables. They don't have the data line.
Well, you got to look real hard when you buy them, but so
right.
On this one, this is one of those. Okay, this is one of those short cables here. So it goes from this board up to my Raspberry Pi, and that's all longer it is. But that's a mini, that's not a micro. So
okay.
One of these days I have to track down the ones for micro to make sure I have the right ones. But yeah, you can get short cables, and that's not really an issue. Now there are reasons why you might want to go with asynchronous serial as opposed to USB. And I might talk about that too. I got stuff written on my list here. Here, let me specifically point that out.
Well, the one reason I was thinking of it is that way I can connect up to the Arduino IDE and still have my serial to the Raspberry Pi.
Okay, so it has the USB connector and it's got one or more extra UARTs exposed on the pins.
Yes.
Because some of the original Arduino stuff, it had a USB connector on the board, but then that went through an FTDI chip and went to the only UART that was on the processor chip. So you'd think you could use it for both, but you can't. So a way to get around that, you can use, again, this thing I just held up, the guy put on a Teensy 2.0. And it's essentially like the Arduino chips, but he used it's like a 32U4 or something. And it's got a USB connector directly into the chip. And then it's also got the extra UART on the chip. So that was a way he got around the fact he could talk USB at the same time he's running a UART on the thing.
The Itsy Bitsy has that also.
Okay.
At least it says it does. I haven't verified it yet, but.
Okay, that's for the moment. That's all I wanted to say about that right now, I guess. So
Now, what I'm hoping is that whatever is on the Raspberry Pi side can have a yes, I'm here type message so that I can have during startup, send out some message to the Raspberry Pi and it says, yes, I'm here. So then I know that I can use serial 1 rather than just serial 0.
what's a serial 0 and serial 1?
Serial 0 is the USB serial, so that would go to the serial monitor on the IDE.
Okay.
And serial 1 is what I would be connecting to the Raspberry Pi.
So on Linux, you typically, when you connect something up, it generates a device driver. So it's gonna name, when you plug that, say you plug a USB port in, it's gonna say, oh, I see a new USB, and it's either gonna call it a TTY ACM 0 or TTY USB 0, depending on the type of device. Probably your board is probably going to generate an ACM 0 type port. And then what you could do, you can use udev rules and say, if you plugged it into this port, or you can go out, read up the serial number of your device. There's various ways to do it. You can say, rename that to Itsy debug or something. So then when you go to use it, just every time you want to talk to it, you just say, like say in your serial debug, you'd say connect to the Itsy debug, because that you just create the name of it, and you can set up these udev rules so it's smart enough that whenever you plug it in, it automatically knows what that is. Because otherwise, you run into the problem. Say you got a bunch of, say, Arduino Nanos you want to plug in. Each time you plug one in, it generates a USB 0, USB 1, USB 2, and you have no idea what the different boards are. So that's why you use these udev rules to try to identify them. And that way it takes care of that kind of stuff.
If I'm using a USB cable to connect the Itsy Bitsy to the Raspberry Pi, but if I'm just using the transmit, receive, and ground.
So just in general, Linux uses device drivers for everything. So when it sees a device, it creates these names for it. So I think the physical UART on that board is going to be called TTYS. I think it's probably going to be called TTYS0. So it already, in order to use that port, it's already got a driver set up to run that. So you just have to know what it's
even
called.
If I'm just using one of the 40 pin.
Yeah, you want to use you want to use a UART no matter what, and basically anything on Linux to talk to anything, it generates one of these device driver names for it. So
okay,
so should already be there, as long as that port is enabled. And again, it goes back to the problem is that, are those pins used for the Bluetooth? If the Bluetooth is turned on, well, I think Linux still has to know it. I think you're gonna have to turn your Bluetooth off in order to use those pins. But I think either way, Linux is already assigned a device driver to that UART that's out there, so it already knows where it is and what it's called. And it's just the type of device, they give it different names. And I was thinking the standard UARTs are called TTYS0 or TTYS something else 0, depending on what kind it is. So anyway, that stuff should already be there.
Okay. I'm sure we will be talking again about this as I get further down this rabbit hole.
And back to the udev rules, you really do need those, because otherwise, as you plug stuff in, the names keep changing and moving around. So at some point, you have to figure all that out so you can lock all that stuff down. So you know that every time you turn it on, you know, you're going to talk out the physical UART to your other device, and that's, you know, named so it knows how to do that. And then whatever your USB coming from the device is, you know, there's a name for that, so that you just, whenever you run something, like say you're going to run a program to talk to a UART, then put in for the port name, put in that /dev/tty s0 or whatever it ends up being called. So
Okay.
yeah, so people do have the stuff figured out. It's just more the endless stuff that you have to learn in Linux to make all the stuff work. Just the long
Okay.
journey.
I just want to have it done by next October.
You're not gonna have it done by tonight when it snows. Actually, it started snowing already. So
No, I won't. Yes, I know it's snowing, and no, I won't have it done.
okay.
Terry, I put the UDEV rules that I'm currently using in the chat, just
Okay.
so you have an example. The particular, I know you're not going to be an expert on UDEV rules in one conversation, but you'll see in that example a bunch of numbers, 8-1.4 and anyway, those are the unique identifiers for a USB cable being plugged into a USB port. There's other ways to make things unique, but just so you have an example.
Okay.
It turns out this stuff is really complicated. So when you get ready to do it, you know, just raise your hand, and where's the little button here? Oh, I don't see it. So somewhere on here, you can raise your hand while this is running. But anyway, just raise your hand and say, I want to do this now, because there's various ways to do it. You can either go out, let's say on the Raspberry Pi, I find it easiest to just take the physical port number. See, you've got on the Raspberry Pi, it's got 4 USB ports on there. So they're called something like 0, 1, 2, and 3, or whatever they're called. They actually get some big long name for them. But you can say, if anything is plugged into that device, then we're going to call it whatever, say call it IMU or call it ITSI or whatever you want to call it. And another way, you can actually go out to the device you've plugged in, and it has things like serial numbers and manufacturers and UIDs and all kinds of stuff you can pull up. The problem is when you're buying stuff from China, like say the Arduino Nanos from China, they all have a serial number 0 or they're all 1 or whatever. So it turns out there's nothing about the board that is unique, because you can write up these rules and say, okay, go out and look at the board and look at the the manufacturer ID and the manufacturer serial number, and based on that you can make it work. But I finally just gave up, and on the Raspberry Pi I just say, if it's plugged into the first USB port, and there's examples on how to do that. Say if it's plugged in that port, I'm going to call it this and that. You just have to make sure you always plug the cables in the same place every time. Or you can actually get to the point where you say it's going to be the first USB port, but also make sure it says that it's an IMU or whatever, by looking up the ID stuff. So again, it's a big journey and a lot of screwing around, but once you get it working, it seems to work fairly well.
Okay.
At least I don't recall it all falling apart. If you plug in a new device, then it might screw something up, but yeah, it's like everything else in Linux.
Okay. That was all I've got.
I was looking at my list
If
here.
you want to go,
Yeah, so I was looking at my list here, and since we're just talking about the serial stuff, you're saying you could connect, wires directly from those 2 pins on the Raspberry Pi, the physical UART, to the 2 pins on your little board. And what I was thinking about doing is taking a USB cable from my ROS computer, say in this case a Raspberry Pi, take a USB cable and plug into an FTDI adapter chip, and then from there take those UART pins and connect to my development board. And there's several reasons for doing that. Now you're going to get the same advantage if you're using a physical UART on the Raspberry Pi, as long as nothing weird happens there with it, that'll work fine. But the problem with trying to just plug a USB cable directly from your ROS computer onto your development board that every time you unplug that cable, that interface just disappears. So like say you're trying to program this stuff in Arduino, and you write up some blink code, or you write a code that's going to put a hello world message out, and if you unplug that cable, the port disappears. So if you fire up your serial monitor that connects to that port and it's showing the text messages coming out, if you unplug that, well, the interface just disappears and it goes away. And that's real annoying, because then when you plug it back in, it takes some finite amount of time for it to come back up. And if you put it out a message that says program startup, today's date is, you're gonna lose all the first messages, because USB is screwing around trying to get this stuff started up. So in my case, if I have a USB cable to an FTDI adapter, then even if I turn my development board on and off or reset it or whatever, the interface stays there, so that keeps working. And you're going to get that same advantage by using the hardware physical UART on the Raspberry Pi. So because even if you turn your eval board off, that interface is still going to remain there. So that's a big advantage to be able to do that, at least when you're debugging, because it's so annoying. Because otherwise, if you got the USB cable hooked up and you say push the reset button on your processor, well, then the interface disappears and takes half a second or whatever to come back up. So that's always been a pain. So I decided my stuff I'll probably do, have a USB cable to FTDI adapter to my eval board. And the reason I was thinking about using the UART is because goes into another one of my complaints here. I was trying to figure out the bootloaders, and I've been trying to use this little blue pill board here. And here, pardon me a moment. I don't know why my camera's screwed up. Maybe I need more lights in here. Anyway, I got this board, and I'm having a lot of problems trying to get the USB to work. And I think when I start rambling here about bootloaders and all this other stuff I've been doing, I think it's fairly reliable now that it is going to work. But I don't know if I should jump into bootloaders next. So anyway, this board has like 2 or 3 extra UARTs on it, I think. So I could use the UART instead of using the USB and just avoid that completely. And that would, as I was saying, then if I hit the reset on the board, or I download the board and it goes for a reset, I don't lose my interface. So if it's putting any messages out over the USB, I can still get those. Which means if I wanted to, I could. See, my option is either just plug in directly like this. So I've got the USB cable plugged in. I got the USB cable plugged in, and then that just goes right to my ROS computer. And in general, in normal life, that will keep everybody happy. You power everything up, and all the interfaces select, and I can say run either my own messages or run ROS Serial across that, and everybody should be happy. But if it turns out that interface is somewhat temperamental, then I don't really want to do it that way. And in fact, even on my to go back and tell a story from my Sammy 2 robot, when I was playing with that, I had that big eval board. I had this one on there, and it's got wrong end of the board. It's got the debug. There's a debug chip on the board here, so it's got the debug interface, and it lets you. There goes my thing again. So it's got these blue wires. So you can solder wires onto this chip and solder onto a UART that's out here. And then it will actually take, if you do a print statement from this chip, it goes out the cable and goes out to whatever you're talking to. So that's how I was talking to Ross originally. And let me turn my background off. This is not going to play today. Background.
Are you powering that little blue pill from the USB on the ROS?
Well, that's another good question. And on my, hold on, I might have to go turn some more lights on if this isn't going to quit screwing up on me here. It depends. Right now, I'm just powering it with either if you plug in the USB, it powers it. And then it's also got this debugger plugged in. And if I plug that in, that'll power it. And Juan claimed that if he does that, if he plugs both cables in the same time, he says his debugger gets really hot. And later I realized he might be plugging one into one computer, one into another computer. So that might be a problem. And then on my Sammy 2, where I had this board, what I did was I've got one of those little step down converters. So I've got my battery voltage coming in, and it's a 12-volt battery, and that steps it down to 5 volts. And then it turns out that whenever they build these boards, they'll have a from this USB connector, or maybe even this USB connector, the power coming in goes through a diode and then drives all the 5 volts on the board. But they don't put, then somewhere there's a pin on either here or up here. There's a pin that says VN, but that VN does not have a diode on it. So in order to not screw things up, what I did was I put a diode between my 5-volt converter and this board, and then the USB has a diode between those. So whichever voltage is higher is the voltage it's going to use. And that way it doesn't overdrive anything. And if I unplug one or the other, the board continues to run. So
does that diode drop the 5 volts too much?
It can drop it, but if you get those little converters they've got an adjustment pot on. So what you do is you plug that in, you put a voltmeter over on the board side, and then you just adjust the voltage. So whatever diode drop you have, you just adjust that away.
Because the converter that I've got doesn't have any adjustment. So
okay, and the main point is there. If you just put a diode in there, it's not going to care, because on the board, then it immediately takes the 5 volts coming in and runs it through a 3.3 volt regulator to run everything on your board anyway. So it's probably not going to matter. You could probably put in anywhere between 3.3 up to 6 volts or so into the thing. Don't take my word for that without looking it up. Go make sure you can do that before you actually start putting voltages on. But I think in general, yeah, I would probably put a diode between that and on your board if you've got something called VN or something like that. Look it up first to make sure what the voltage range is, and that's what it's for. But then, yeah, put a diode between that and the external world if you're going to power it that way. And I see if you're not going to have the USB cable hooked up all the time, that yeah, you do need to power it some other way. And that was my reasoning too, that I wanted to be able to power it directly. As soon as I turn on the main power switch on the robot, I want the robot itself to power my microcontroller board, as opposed to having to power it up through USB, because mine will run without the ROS computer on at all. And if that's what was supplying the power, then that could be, that could be an issue. So yes, that's the point on that. I forgot what the original question was. You said something about powering it through USB or something else.
Well, right. I asked whether you were powering it just by the USB to ROS computer, and what it sounds like is you're not.
That's correct. It can be powered either way, the way I've got mine set up. And right now on this one, I'm just starting to experiment with it. It's got nothing. It's just the board, and if I wanted to, I could put, well, in this case, this could be powered both ways, because I can plug this one in and powers it, or I can plug the other end of this cable in and powers it. And then if I find somewhere on here, there's a pin that says VN or something. So, I really should have that hooked up to drive it that way too. So, well, that's still down the path, so I haven't figured that out yet. So I guess I'm just gonna be red today. So anyway, back to the serial stuff. Yeah, it's handy to have something that's not directly USB, that you keep losing your interface anytime you do a reset or a download or anything else happens. So that was something I'd thought about, and on my Sammy 2, that's what I've done. I was going to tell the story of that. So I had that eval board hooked up, and I was going to from the debugger USB port, it was going to a USB hub, and that hub is going to a Raspberry Pi. And that's just the way you hook stuff up, and it should work. But my board kept resetting on my eval board kept resetting, and I finally tracked it down. If you watch the dmesg, it says, "Oh, I just got a timeout on this USB." They called it USB something. I can't remember, USB serial or something. And it, for some reason, it was just cranky. There's something between Linux and that hub and that debugger port. Just randomly, it would time out or cause errors or something. And then my eval board would reset on me. And that, I found that to be very annoying. But then I found out if I, instead of going through the hub, if I go directly from the debug port, the USB cable from there and plug it directly into a root port on the Raspberry Pi, that it stopped resetting. I could still see messages popping up under dmesg. So it was still cranky. It still didn't like that situation.
Dmesg, what's that?
That's a Linux command. You just type in dmesg, and that shows you a whole bunch of stuff going by. And while we're at it here, let's see, how do we get chat to work here? So you can either just type that in, or you can say DESG -- follow, and that will.
And
What that does, anytime you plug in a new device or something changes, it shows you stuff. Because otherwise, you get like, you type in dmesg, you get like 1,000 lines of stuff dumped on the screen, and it won't change anymore after that. So instead of type in dmesg anytime you do anything, just do the dmesg -- follow, or you can say, I think I noticed dmesg -w is the same as doing a -- follow. So the -- follow is more apparent to a user, because here, that I can't edit that, can I?
no.
I can delete it later, I guess. I can say -- -w. So
Now, before we move on, I just want to verify what diode you're using. Would a 1N4001?
That should work. That's a 1 amp diode, and you've got a small board. Mine, I think I ended up putting a 3 amp diode on it because I was powering the board, and the board was powering my radio control receiver, and it's powering some other stuff. So I just put the larger, I think it's a 5 amp module, power module, and then I think I put a 3 amp diode in between mine. And I don't think that the type really matters, whether it's just a standard, like a power supply diode, or you use a Schottky diode. So the 1N4001, that's just a standard power supply diode, and it's going to have like a 0.6 to 0.7 volt drop, and it's not a fast diode, but again, it's DC, so it doesn't really matter too much. So to answer your question, yeah, that should work.
Okay. What was the 3 amp version? Just because I'm not familiar with it.
I might have used a Schottky diode. It might have been like a 1N5401, I think is the numbers on those, or there's about 1 million diodes, so that's whatever I happen to have at the time is what I put on there. So let's see if we beat that to death. Yeah, it's a good point. How do you power these things? And it's a good point. How do you connect them together? So I guess maybe we've covered all that. So let me back up and say, so I think it was last week I was saying I should take my blue pills and see if I can figure out how to get those to work, and if I can make them work like an Arduino, then I could go down that route. So I pulled all my boards out, and it turns out that all 3 of them seem to act differently. I tried loading bootloaders on them a couple of years ago, and it turns out one of the boards still apparently had a bootloader, and if I'd run it under my Windows machine and I picked the right download option, I was able to actually load the Blink program, download it to the board, make a change, and that was working. I thought, oh, that's great. And then later, so now we have to move on. So anyway, I had that working. So it was working like an Arduino. I just say, go to my Blink program, say upload. It would automatically stop the board, reload the code, and come back up running. And everybody seemed to be happy at that point. So then I moved on, and I thought, if I'm going to use these blue pill boards, and I want to use quadrature decode, that's the whole reason for using the SD micro stuff. There's a guy on Homebrew Robotics that has a GitHub where he wrote up code to do the quadrature decode on a blue pill. So I thought, well, I'll start there. So I downloaded his code. It's just like an Arduino type sketch. I loaded it in and into my Windows machine, and I said compile, and it popped up just hundreds of errors saying it can't find it can't find this define in this header file. It says the type defs don't match. It said you're trying to convert between integer types. And I thought, I don't know. So I looked at that for a couple hours and finally decided I wasn't going to figure that out. And I thought, well, I should load this on a Linux machine anyway. And that would give me a fresh install and whatever. So I pulled out my Linux machine and found the newest 1.x Arduino stuff. Because when they go to 2.0, they changed the user interface. I didn't want to deal with that. So I loaded the newest Arduino stuff that I could. And then I went through random YouTube videos that says, here's how you load the STM32 core so it understands this type of chip. And I took somebody's video and I do one or two, maybe I got it right the first time. I picked one and loaded that in. And then I said, compile that code for the encoders, and bam, it says, oh, everybody's happy. We're all ready to go. So I knew there's some difference between those. And then I thought, okay, now I got to do is put that on the board to test it. So I went to it and I said, upload with the ST-Link interface, which is that little module that's on my board. And it says, oh, can't do it. It got a core dump or whatever they call it, whatever the modern term for that is, where it just blows up and doesn't do anything. So after much digging, it turns out that you have to go out and specifically load the drivers for this ST-Link module to work. And I found one guy's description. I followed that, and he downloads a GitHub and compiles it, and then did a lot of manual installs and copying. And that one, it looked like it was trying to work, but it obviously wasn't going to work. And then it was time to go to bed. So I got up the next day and thought, well, maybe if I uninstall that and look for a better version. So I painstakingly uninstalled all that crap and found another YouTube video, and the guys to step me through it. And I went and tried that, and that did work. So I was able to get my ST-Link will now download from Arduino. So I can say, load up a Blink program, say select the ST-Link programmer and say upload, and it will. So I was happier at that point. So I went back to the Windows machine and thought, why is that not working? And the STM32 core that I loaded was different between the Linux stuff and my old stuff on the Windows. So I thought, well, how do I fix that? So I was going to say, how do I delete the core that's there? And I went out and looked at the board manager, and it said, under this description, it says deprecated, deprecated, deprecated. I thought, oh, well, that's why it doesn't work, because it's old and it's a piece of crap. So I was able to figure out how to uninstall that. And then I installed the one that was on the Linux machine. And then Windows popped up and says, oh, hey, it compiled, everybody's ready to go. So you're all set. So I thought, okay, I'll upload that one. So I plugged in the ST-Link and said, upload. It says, oh, no, I don't know I don't know that module anymore. So when I swapped out my 32 core, it threw away my drivers for my ST-Link. So I think someone was saying, now I have to go out and install the ST-Link programmer package for Windows, and that will fix that problem. But I haven't got around to doing that yet. So I got to the point where now on Linux, I can write code, and it seems to be modern enough code that's going to work. And I've got the one programmer function to work on that. And so somewhere along the line, I think it was when I switched over to the Linux machine, I thought, okay, let me try that bootloader that's on the one board that the bootloader still works. And I selected whatever option they told me. And I did like a Blink program. It says download. And it comes up, says, it started going through, it says loading block. Then at the end, I think it says download complete. And then it wouldn't talk to me after that. So it did understand the bootloader, and it downloaded code to the board. But now that bootloader seems to be gone. So there's a problem with that. And I kept running into the problem with the bootloader, and I kept saying I should fix that. And I dig for hours, and finally I'd keep giving up on it. So last night before I went to bed, I may have found the answer to that, but let's go back and move on with that. So anyway, I can't do any of the USB download because I need to have a bootloader on this particular board to make that happen. But if I wanted to, I can use the ST-Link programmer, and I should be able to get that to work under Windows again. Or it's got the serial download option, so you have to move. It's on the board. It's got these jumper blocks on the board right here. So you have to move one of these jumper blocks, push the reset button, and then put it back. And that's supposed to that puts it into a serial download mode. So there's 2 pins on the board, and you can hook it up either with an FTDI adapter or like Terry's doing, connect it directly to his UART on his ROS computer. So that's another option you can do, but then you have to go out and you have to monkey around with the jumpers to get that to work. But I haven't given up on that completely as a final solution, because if it's connected to a UART anyway, I can just use that UART to talk out like Terry wants to do. And then whenever I want to reprogram it, I could move the jumper and do it that way. Or I thought I could probably get clever and have a little extra microcontroller sitting there that knows I want to download, and to wiggle those pins for me to put it in download mode. Or possibly in your code, say you got code running on the thing, you send down a special message saying boot or serial boot or something. And I think internally it can just jump to the bootloader, and that will, bypass having to play around with all the jumpers and everything. And that will work fine until it blows away your bootloader, and then you'll have to, do the jumpers and the push button. So you might have to do that to recover it. But so there's lots of different ways. I went down that path on trying to figure all that stuff out. What would be the way to do that? So let's see. Back to the fact that I was trying to get that quadrature stuff to work, and when I loaded the code, it initializes 3 channels, and then it's supposed to read the encoders, and it just prints out a line saying count. In my case, this is count 0,0,0. And since I haven't gone to the trouble of hooking up an encoder, I assume that code's working, and I assume if I hooked up an encoder, that would actually work. So let's see, my thought. So I haven't moved on with that. I just know that it will probably work if I hook up the encoders. It's probably working. So that's something I need to merge in later. And let's see. So I talked about the Arduino on Windows, the Arduino on Linux, the ST32 core was a problem, the ST-Link stuff. So on either one of my computers, I have to load the ST-Link drivers separately. And for some reason, what I did it the first time, it worked, and now it doesn't on Windows. So I got to track that down. So then back to the bootloaders again. So it turns out I found a YouTube video a couple years ago that said, "Oh, I told you 6 months ago how to load this bootloader, but now throw all that out and load this new bootloader that's going to solve all your problems." So that's what was on the board, and I didn't understand any of this stuff. But it turns out that was an HID bootloader, and HID is some kind of a user. I can't even think what HID stands for, but anyway, it's one of the various methods you can use. So it was a bootloader written that can understand that. And then you go to the Arduino when you say upload, and one of the options is HID 2.0 or 2.2 or something. So technically that should work. Now, when I try to do that on my Linux machine, it says, it gives me a line saying JavaScript, blah, blah, blah. It says in this directory, it says HID _upload not found. But if I go look in the directory where they told me to find it, there's one called HID _flash. So probably that's just a naming convention that somebody screwed that up, where it's pointing to the wrong program to run that. So that wouldn't run, even though I think did it earlier work? So somehow I tried to do that, and that's why I blew the bootloader away on this again. So that was a concept there. You could run the HID bootloader, and everybody kept saying, "Oh, there's a resistor on the board," because here's the board with so somewhere on the back here, there's a resistor that they say it's a 10K, but it needs to be 1.5K. And somebody says, "Well, solder this resistor on here." They'd say solder on a 1.8K, and that in parallel with the 10K is supposed to give you 1.5K. And they said that's going to solve problems. Well, that didn't affect my stuff any. And then so when I was digging through the bootloaders, it's not obvious, because people say, "Well, it started with this one and went to this one," and there like 20 or 30 of these things around, and I can't figure out what is what. But I found one that's right on Linux now. It says I can use the STM32 Arduino bootloader. So I was trying to search for that, and that took me to the Roger Clark from Melbourne website, which is also called. He's tied in with the STM32 Arduino development group, and I kept seeing this stuff and I couldn't tell what modes this stuff would run in, or what it's supposed to be connected to. And then finally, just before I went to bed last night, I was on that GitHub, and it kept saying, well, look in the wiki. And I clicked on the wiki, and it's inside the GitHub, the little tab at the top that says wiki. And then I found a wealth of knowledge there talking about, number one, just the bootloaders in general, and number two, how this specific bootloader works. So I think if I get his version, the ST32 Arduino bootloader, if I put that on my board and then under Linux select that one, that possibly that will work. And it may be smart enough that you know, if your code's just running, you say upload, it'll stop the board, put the new code in and reset the board and come back up running, so I don't have to screw around with jumpers. So there's still a whole exploration there. And the first thing, of course, is it's got to work. It's you know, whether it's got jumpers or not, it has to be something that works on that. So that's kind of where I left that, and I'll go back to that here, you know, eventually on that. So I'm still trying to think, you know, as we were talking about at the last meeting, if you can do all your programming in circuit without having to tear it apart, that'd be great. If you can do it without having to, you know, fiddle around with jumpers and push buttons. If you absolutely have to do that, you can solder wires on and put push buttons on the outside of your box. So, you know, you can just walk the box and say, hold down the boot 0 button and then reset it and then release the boot 0 button. And that without having to tear it apart, at least that will put you in a mode where you can then go to your ROS computer or your whatever your big computer is and say, reload that board, and then hopefully that would work. So that's, I still have to dig into that. And as I say, I was the other confusing thing was, when I loaded the Linux and I wanted the STM32 core to put on the board, he says, oh, use this link. And it's like https // it says dan.drone.org, and then listed the whole thing out where you find this JSON file. But if you click on that and go to there, it just brings up a, you know, instead of bringing up like a GitHub or something else, it just brings up a single statement that lists out the website of the STM32 Arduino website, and that takes you into the forum. So it dumps you into this forum, but nobody there seems to know what this code is. So I was digging through this big long thread of several hundred messages, and finally they decided that that particular version of this JSON file was built by this guy named Dan Drone, and he just takes the stuff from the STM32 Arduino GitHub, and he compiles it and just stores it on his webpage. Nobody says that, but that's apparently what's happening here. So if you want to run this stuff, you have to, I guess you can point to his stuff and load it, or it may be somebody else, because somebody says, oh, I think that's identical to Roger's version. And it's this Roger, I forgot what his name was, Roger Clark from Melbourne. So, but they don't seem to equate these together, and nobody seems to know what's going on. So I think after reading all his message, I finally decided what I have is the latest current stuff from there. And then if I go to the bootloaders and load that bootloader, then theoretically this stuff should all work together. So it's just a matter of going to track that down and see what happens. They kept referring to the official. Oh, or you could use the official STM32 core, or you can use the stuff from the Arduino site. And I still don't know what the official version is, because they won't tell me that either. So it's just all really confusing. And if I just get to the point where it will reliably work over that bootloader, then I can decide if that's the way to go, or do I want to use the serial mode and do it that way, which again would give me the advantage. It gets away from the USB port coming and going as you do things. So I think the only other thing I was going to point out is I've still got this STM F407 board. This is the one that Juan found, and it's got the same chip as you got on the bigger eval board here. And so theoretically, although it looks like the one chip is much bigger, maybe it's optical illusion. Anyways, so this is the same chip on this one, but it's got the dual row headers, so it'd just be more soldering and playing around. And the advantage is it is a Cortex M4, and I kept saying for the last several years that these F103 boards, I said, well, it's STM 32 F103, I think is what the chip is on the board. So I assumed that F103 meant it was a Cortex M1 because it said F1. Well, it turns out, no, it's a Cortex M3, even though it's called F1. So it's F103, but it's actually a Cortex M3. So I've been telling people the wrong thing all these years. So this one's a Cortex M3, and then these boards are Cortex M4, and so they're newer and better, and they've got hardware floating point, whereas the Cortex M3 does not. And then the Cortex M3 only has a serial bootloader, but it is built in, so you can't blow it away. You just move the jumpers, and it will load over serial. And then the Cortex M4, apparently the jumpers, you can set it, and you can run something called DFU mode. So again, it's another built-in bootloader. So on that board, you can either select the serial bootloader or this DFU mode. And as long as you got something that'll talk to that, then theoretically you can program it with those. So just still more things to go down the path here and try to figure out what's going on. And I haven't decided on the F4 type boards, which have the Cortex M4 processor that's got the built-in bootloader. It's got this built-in serial bootloader and built-in DFU bootloader that you move jumpers around to make it work. I don't know once that's running, can I get by without having to do the jumpers, having to fiddle around with that if I want to reprogram it, or if it'll do it automatically. So that's yet another thing to try to track down. So other than that, I guess I haven't been doing anything other than a lot of this. It was just to avoid having to actually work on the thing. So but I did find a piece of perf board and bolted down to the top of my robot. And if I put on socket pins, so enough pins to plug this board into it, and then I need one connector for each quadrature. I need one connector for the power driver board. I need one connector for the RC servo. So I can solder some header pins on there and just wire on the back of the board, hook those together, and I should be able to ready to actually try this stuff. And once that hardware is built, it doesn't really matter if I use I was distracted by Al's post there. What was I saying? I totally lost my train of thought. Blah, 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 blah. I forgot what I was talking about. So anyway, that's the thing is, once I get this thing stuck on a perf board and wired up to my hardware, it really doesn't matter if I use the Arduino IDE to write the code, compile it, and download it, or I switch back to the ST Micro IDE and use their libraries and their methods. I could program it either way, so it's not really it's not a problem, whichever way I do it. Other than I see when they're doing the Arduino stuff, they've predefined which pins are going to be for the quadrature encoder. And then it turns out, by looking at it, it seems like whatever I select for quadrature encoder, it's going to affect some of the extra UARTs on the board. They seem to owe the pins overlap. Now, these things are very smart, and you can go into the, if you're running the ST Micro stuff, I can say, give me a quadrature decoder, give me another one, and it just starts assigning pins. And if I decide, well, nah, but that conflicts with the UART, then I can say, switch the pins on that to something else and lock it down so quits trying to bite me. And then I can say initialize the UART. So it allows you to multiplex these pins and decide what you actually want to run. And if it conflicts with something, you might be able to switch them to some other set of pins and make it work. So that's a big advantage there. And you can probably, if you know what the commands are, you could probably do that in the Arduino code. It's just simply when you run your setup, say, or a setup. Now let's see. I don't know how you do it, but you got to go in. You got to go in the code and say, move these pins around so they're where you want them. So I don't know if that's really the way to do this or not. So it's just more digging, I guess. So I think I'll stop babbling now.
So to do a blue pill in an Arduino environment after all of your research, do you have to use, do you have to solder on that resistor, and do you have to use the Oh, the add-on bootloader, or can you do it through USB?
Well, you can't do it through USB unless you have a bootloader, I believe. Now, whether you have to solder the resistor on or not, that I haven't proven that. People keep saying, "Oh, you have to do that because the spec says it should be this other value." But you know, I was using the USB on these without it being a problem. Although I found somewhere as I digging through the source code, it said something about in order to get this board to reset from the computer, somebody did this trick where you do something, you reinitialize one of the, I think the data line from USB to just a GPIO. And it turns out they had to put a smaller resistor on to make it that happen reliably. So even though everybody keeps saying the spec says you have to have a 1.5K resistor instead of a 10K resistor, I don't think that's true. I think it's some trick they did to make this bootloader work is why they have to have that. And everybody's propagating the wrong information. But so to answer your question, I'm not sure yet. I have to, see if I can get a bootloader to work, and then you can program it through the USB, and then find out what the caveats are to that. If you have to, if you have to do something like manually reset it or manually move jumper pins around or whatever. So I don't know on that yet. And the resistor, again, I'm not sure if that's really needed or not. So I do know that one of my boards, I popped that 10K resistor off, so it's got no resistor, and it will not recognize the USB. So it has to have some resistor on there, but I'm not sure what the value needs to be on that. So I'd say don't jump into this yet. I know you said you've got a whole pile of these laying around, but we don't need other people going off on a wild goose chase until somebody figures out, how it actually works. So, but in order to just,
Yeah, I went down the path I was going to say I went down the path some time ago, and it just became so frustrating to get them programmed. So,
did you have
anyway.
the little module you plug into it? One of these? Did you have one of these? Or were you trying either the serial or the USB to make yours work?
Yes, I think I had a couple of them.
But it turns out if you're willing to use that module, you can program it from an Arduino IDE as long as you set everything up right. And if I would go back to the ST Micro IDE and their libraries, I could also program it that way. And I think the board, by default, it's got that serial bootloader built into it. So if you wiggle the pins, you can get that to fire up. And I think either the Arduino or the ST Micro stuff will directly program that. It just really comes down to this bootloader, trying to get that figured out. And number one, find one that works, find what works reliably and doesn't get overwritten, every 2 or 3 times that you program it. And I don't know how that's happening or what's happening there. So, and that might just be my imagination.
For me, it was access to the board after you get it programmed. I mean, if you have to go back and reprogram it, that's where I think I abandoned using them, because I couldn't, having to use that module that you just held up is really impractical once you sort of covered it up with a wheel encoder.
I also found out
anyway,
that I seem to be able to leave this plugged in all the time, just like this. And if I don't plug this into USB, it doesn't seem to screw anything up. And then if I want to talk to it over, I can power it over USB and everybody's happy. And or I found on my computer, if I plug this thing into plug this USB and this USB cable into the same computer, I don't seem to have electrical problems like Juan said he was having. So theoretically, you could leave both of these plugged in all the time. And that way you just simply, when you get ready to program, you just say, program the thing, and it goes out through this debugger module and programs it. And once it comes up, then it'll start talking over the USB cable. So that, again, that's just more stuff to, to prove that it works and to prove that it works reliably. And then in a month, say, is it still working or is it randomly causing problems? So that's just more, as I say, more journey there to get that to work. And in reality, I kept thinking, well, maybe the blue pill board's not very good, but it's just a chip soldered on a board. There's no magic on the board, and that's part of the problem, because this is an extension of the Maple Leaf board, And the Maple Leaf board had this processor on a board, but to put some extra parts on it to make the downloading work better. So theoretically, you know, if instead of buying this board, you'd buy the Maple Leaf, it's got more, it's got more hardware there to solve all this downloading problem. But somebody claims they've got this to work on this board without doing any modifications other than maybe that resistor. So again, it's just going to have to be tried and see what happens. Oh, and one other thing, I see I didn't write it on my list here, but you know, they were talking about the serial stuff, and then ROS Serial came up. Now, when I would always do my stuff, I would just have in order to communicate between my microcontroller board and my ROS computer, I would just simply have a print statement that would say, like say up on ROS, I had a node, I think I'd probably call it my machine interface node, and it was probably written in Python. So I'd start that node up, it would subscribe to something like say command velocity. And then in that program where you get a callback on command velocity, it says, I just received this message. I would just strip off the forward velocity and the steering field. I'm going to call it the steering field at this point without spending half an hour explaining all that. So I just strip off those two values. And then in the code, it would say print to this port. So they would be connected by a USB port. So I just do a print. I'd create my own format. So I'd say something like E, or I'd say C for command velocity, comma, the first value, comma, the second value. I just do a print and I would shove it down the thing. And then on my microcontroller, it just says, oh, I just received a line of stuff from ROS. And it just says, oh, it starts with a C. That means it's for command velocity. It parses those two values and uses them. So I just use that concept, you know, going either direction. If I want to generate odometry information on the microcontroller, it generates my 5 values. I just so I do a print statement that says like O for odometry, comma X, comma Y, comma theta, comma velocity, comma rotational velocity, and do a print, and that sends it up to the Python program, and it says, oh, I just received a line from the microcontroller, strips off the values, and then publishes that as an odometry message and as an odometry transform. So that's the way I was originally doing that. So then when I went and looked at the ROS Serial stuff, it turns out you look at the examples, they're very simple examples. You just simply say include ros.h in your Arduino code, and then under setup, if you're gonna, let's see, I think I don't remember if you have to set up the serial port or not at that point. I don't think you do. I think the code automatically does that. And in setup, you say something like, you know, initialize the ROS serial or whatever, and then in your code, it just simply says, I want to subscribe to, and you have a mess. It looks a lot like ROS code. So you say, I want to subscribe to this type of message. And that had me going because after I got all the stuff loaded, it loaded up what looked like thousands of messages, but none of those had a command velocity message in there. So I went out and looked at Al's code, and it turns out you say, I want to subscribe, and then you say it's a general messages : twist. And that the twist is the key right there. That's a message type that is supported. And then the next field, you say that it's going to be called / command velocity. And the next field is the callback, that when you receive this message, that's the stuff in your Arduino to execute that. And then the rest of it just, it looks like ROS code. So in your callback, it says ROS callback, comma message. So that message now has the message you just received. And then just like you do in ROS, you'd say, okay, a message dot velocity is going to be put into velocity, and message dot angular velocity is going to go into steer. And so it turns out that, you know, I kept avoiding it because I thought, oh, it's going to be too complicated to figure this out. But it looks like, yes, from that standpoint, it looks like it will work if it's not taking up too much room in my microcontroller in order to do this stuff. So the point was, if you go through the examples and load up the code, you have to load the libraries on ROS to do I think it's called the ROS Serial.python. That's the program. That's the node that runs at that end. And then it loads another one into Linux. And then from there, you execute, you do a ROS run, something about load libraries. And it's smart enough to take that stuff that you compiled and somehow wedge that into your Arduino installation that's on your ROS machine. And then after you do that, it just apparently seems to work. So I'll play with that some more and see where I go. I started off, they had a hello world program that just simply initializes a thing, creates a string out. It's going to publish a string output called chatter. So this is like the chatter example under the tutorials. And then down in the code, it says load the string hello world into whatever the message is. And it says publish that. And it just magically pushes it up and goes up to the Python node. And it just magically publishes that as a chatter topic. And that I tried that and that did work. And then they had one called ODOM. And if you look at that, they've taken the odometry tutorial and stripped the code out of that and stuck it into this Arduino program with the ROS serial on top of it. So you fire that up and it publishes a transform under ROS at like, I don't know, it's running like 20 times a second or something. And you can see the values changing. And that odometry tutorial basically says, here, let's just create a fake values of driving around in a circle. So it's doing this, shows it driving a circle. If you go watch it on the transformers, you can see the numbers changing. So that does indeed work. So it's just gonna be a matter of figuring out, how many messages can you define? Because somewhere it said there's equates. So if you've got a certain size processor, you can do like 5. You got a bigger processor, you can do like 25. And so it's just a matter of figuring out, just start off with the simple stuff. I think it's just going to work. And then if you have more than a couple of messages, you might have to look at it and decide, you might have to change the equate to say do more messages or something. But there's actually, for what I'm doing, there's very few messages being passed back and forth. From ROS, you have to send down the message that says, here's my forward velocity and my steer value. So that's one message. And once it gets down to the microcontroller, it strips those apart, and I can send the velocity part of that to my motors to push it forward, and take the steer part of that and send it to my RC server to make it steer. And I was trying to think, am I doing anything else right now? Let's see, I've got.
Will that work? I mean, I understand you're using the acronym for yours. Would that steer value be
yes,
acceptable for the skid steer?
Yes, it all works out. That's the thing. I didn't want to spend half an hour going down the path that.
Okay.
If you're using TEB planner, or if you use the regular planners, you get a normal command velocity, which is forward velocity and rotational velocity. But when you fire up the TEB planner, you can set a flag saying, convert that, instead of rotational velocity, we want to publish a steering angle. And as they say right in the code, it says, you shouldn't do this, but we're going to put that right on top of that standardized message. And basically, we're going to redefine that message. And so it's passing the same exact message down. It's just how you interpret it at your end. So the answer is yes, that will work.
Okay.
And in fact, in my case, if I go to the Ackerman message, then it's got like 6 fields of stuff that it sends down instead of 2 fields. But yes, it should all work. And in fact, I noticed on the messages that it loaded, it specifically had one for Ackerman command message, but it did not have one for command velocity. So it's just one of those things. There's gonna be more digging to figure out how to merge this stuff together and make it work. And Al runs this ROS serial, and I went out and dug through his examples, and he's got a separate steering controller and a separate transmission controller, and both of those subscribe to this command velocity coming in, and one of them picks off the velocity to run the transmission, the other one picks off the steer to run his steering stuff. So that's something else you can do. You got 2 separate modules subscribing to the same message, and that apparently works. I guess I don't see a reason why it shouldn't work. So everybody's happy. So just keep in mind, you might want to go with ROS serial, or you might want to just send your own values back and forth. So it's just one of those things. So I think I'm finally done with all my stuff that I was looking into. And back to your comment about how to power the board. Yes, I need to figure that out. But right now, if I plug in either one of these things into a USB, it powers the board. And just for debugging, that's good enough right now. And I don't have to get the bootloader running. I can write code and get it to program, but I'll probably go back to the bootloader next and see if I can get that. Now that I found actual documentation for it, maybe I'll go back and try to get that to work.
Okay.
So I'm done. I think Terry's done. So Al, did you have anything you want to say? Now that I'm going to shut up.
Well, I'll try to be brief. Let's see. I decided to use the word struggle instead of fight, but relearning ROS Serial, struggling with ROS info command to get debug statements out, because once you subscribe to ROS Serial, I have not found a way to get debug statements in a print or sprintf kind of way working. So anyway, I have got command velocity working in my main embedded code for the tractor controller. I've implemented a mode switch. I'll just canter through the code a little bit. I've changed from one ESP32 PWM generator called ESP Servo to another tool, and I'll explain, or another library to generate a PWM signal. I'll explain that. I've driven the tractor out in the yard to figure out some min and max control settings. I've hard coded my PID for steering, mostly. And the next thing I need to do is work on a PID controller for my speed and implement a dead man switch. And I can explain a little bit about why, and then get to a command velocity mission, simple command velocity mission, where I try to do anything more fancy. But let me just show you the state of a couple of pieces of code. Oh, and by the way, I was looking up, I have the Nano Every, and I was just, it appears that's a 20 megahertz clock speed. And then I went over to the Blue Pill, and that the M3 is at 72. So yeah, now I'm reminded why that Blue Pill was interesting. Let's see, as a reminder, this is the board that,
Before we move on, you were saying that you couldn't get ROS info to work. Are you just simply looking for a way to see, dump the stuff out and see it? Or did you want it to be logged in? I assume that if you put in ROS info, it would probably be logged as a ROS bag. Or do you just want to see the messages?
it was mostly just to see it. I mean, I found a workaround, but I couldn't get the library. There's two particular libraries, and I couldn't get them to work. Or couldn't find one, actually. I found console.h, but it required macros.h, and I couldn't find it.
So you said you mentioned chatter. So you've got a chatter that just sends messages back, because you could just use the concept of chatter, which just takes a string and pushes it up, and just whatever message you got, just dump it into that message and let it publish that.
Which is exactly what I ended up doing. Well, there's two things going on there. You can so this is the include statement that I'm just going to canter through this top to bottom just to show you some of the changes. So this was the old PWM driver. This is the new PWM driver. I guess it was written originally for LEDs. The reason I did that is because it gives me higher resolution. Well, let me show you what I mean by that. Sorry, my laptop. I previously had these two you can't really see them, but full reverse position and full forward position was 58 and 98. That gave me a total of 40 positions, 26 of them to be forward. And there was some dead space in there, so it didn't actually have 26 positions. And I didn't know how to change the resolution in that old PWM library. So that's why I switched to the PWM library. Now I believe instead of 40 positions, I've got a total of 85. So I doubled my, effectively doubled it. 59 forward and 26 in reverse. Pardon the noise if you're hearing any of my noise. Let's see, I did that by changing the library, and that library gave me access to let's see, there it is. Gave me access to this. I can set the resolution, and that let me change the PWM max, to a 12-bit number. And although I don't have full access to that because this is a picture of the servo that I've got. I'm literally, there's maybe a 2-inch metal bar connected to this, and I think the distance traveled is 2 inches, and so it's like, doesn't go very far at all. So that's the driver for, no pun intended. That's the reason why I changed drivers. So that worked out. So far it's worked out okay. Let's see, what else have I changed in here? Here's the chatter that I've put in here to get.
What
some
is
debugs.
chatter?
It's just the name that I gave this function. We could call it Terry's info function if we wanted to.
If you look at the ROS tutorials, they have a tutorial called chatter, and it just simply sends messages back and forth, and they thought it was cute to call it that.
Okay.
So he just copied that name.
And I just have two lines, and I put a delay in there. Don't know if it's required or not. And it's just a way for me to get this information out while I'm doing debugs. Command velocity looks pretty simple. Here's a safety check that I put in to see if I've got a command velocity recently, because if I lose access to command velocity and if I'm in, let's call it automatic mode, I want to stop. So this is a safety flag thing that I added. There's a subscribe statement that Jeff was talking about. The transmission setup, or the servo setup, went from those 5 or 6 lines to these 3 lines to change from that old library to the new library. And again, that's where the PWM resolution is coming in. My main loop hasn't changed. I had to take out all these serial print statements. And so I need to go back and put some sort of better debug messages in there that I have access to. Let's see what else has changed.
That's one of the reasons why I was thinking of using the difference between serial 0 and serial 1 on my Itsy Bitsy, so that I could have serial 1 being what talks to ROS, but I could still have any debugs that I want on the USB if I'm connected up.
Yeah, that may be a way to go. And there might be a more elegant way to solve it than my, info function called chatter, but that's just what I've come up with so far. So I've added a safety flag here to make sure I've got a radio signal. This is basically the command that when the radio signal comes in, and then those are a whole bunch of serial print statements I've kicked out. And then this is the, a couple of things are going on here. It's the implementation of the mode switch. And it is adding, Boolean logic to say if the mode switch is that and the safety switch is okay, then it's okay to steer or throttle the thing. Otherwise, this happens to be steering, so it points it straight. And this is the throttle function that's I'm working on. This is work in progress as we speak. But there'd be two safety flags. Is the LoRa radio working, and is the command velocity, is the latency on that okay? Here's where I need to add, check the safety LoRa radio signal, but I don't check the dead man switch. So I need to add some logic in there to check the dead man switch. And then, yeah, I don't think anything else is really changed. Let's see, back to my min and max control settings. So, I printed this off, went out into the yard, drove the thing around, and measured a couple of things that were 35 feet apart, and counted the number of seconds it took at different settings to get between those. And so these are the actual PWM settings that will drive the thing, more or less 2 meters a second or 0.6 meters a second. Now I have wheel encoders. And so the next step will be to go get those working again and, measure it based on the wheel encoder data. But this was just visual controls because I wanted, before I went much further, I wanted to get some more reasonable values for full position and reverse position. So anyway, that's the journey that I've been on the last week or so. And then these are just the commands that I was issuing to get things going. I don't think there's, go ahead, Jeff.
For your RC servo, where you're talking about resolution and various things, if you looked at servo.h library.
Not that I know of, because I was going into what was available in platform IO for my ESP32.
And there's no guarantee that exists for every processor, but that is something they wrote specifically to talk to RC servos. And you can look to see what it uses for resolutions and ranges and whatever. And number one, make sure it is going to work on your device before you go too far. But
yeah, it looks like it's available from this. I've seen his name before, Michael Margolis. This is the one that I was using. But yeah, that does seem to be available.
Oh, I see that servo ESP32 is probably doing the same thing. So you say you did try that servo ESP32? Or
yeah, that's what I had originally.
Okay.
But then when I got down to it and I was doing, driving, physically in the yard, my min and max positions, it was only a 8-bit resolution. So I only had 255 if I had access to all 180 degrees of the servo, because I'm only using, I don't know, 20 degrees of the servo. It gave me a very few number of positions and I was thinking, as I get ready to try to get a PID working for the throttle, it just didn't have very many options. And I was thinking better resolution would help me. So that was my tortured logic for changing. I've been down more rabbit holes, Jeff, that are probably unneeded, and this may be another one, but I've gone down it and I'm coming back out. So we'll see in the long run if it's worth the effort. Anyway, I'm happy at the moment that I've got, a little bit more resolution to deal with. That's all I've got.
And if you get real desperate, you can pull out a drill and drill a new hole in that arm and move the connecting arm down to they'll give you more range too. The server will have to move further to move that, depending on what how things fit together right now. If you have room to do that, I should say.
You're exactly right. And that servo is mounted in such a painful spot that I really abhor the notion of trying to take that off. But yeah, I could do that. Anyway, that's what's going on with me. Progress in the yard driving. That's always a good thing. And yes, I bumped into a few things.
You are able to go out in your yard and drive around?
With manual radio control.
I just wonder how many obstacles you have, because we still have snow here. We got after our 12 inches of snow, I still got lots of snow piled in the front yard. And over the next 2 days, it's supposed to snow another 8 to 10 inches. So that's I'm not going to be driving in the yard anytime soon, unless I want to drive.
It was 27 degrees here in the mornings, so I don't know that we're out of the woods yet, but at the moment the snow is gone.
It says it's 26 degrees here.
Well, here it's warmed up to 44, so it's we are enjoying a balmy 44.
Okay, so any more robots for today?
Nope, that's all I got.
I'm sure I could ask you questions about PIDs, but I think I'm good for the moment.
Okay.